Hello, so this is Math 114, 5.7, negative exponents and scientific notation. The negative exponent rule. If b is any real number other than 0 and n is a natural number, then b to the power of negative n can be rewritten as 1 over b to the power of n. And if we have 1 over b to the power of negative n, that can be rewritten as b to the power of n. When a negative number appears as an exponent, switch the position of the base from the numerator to the denominator or the denominator to the numerator and make the exponent positive. The sign of the base does not change. So, following that example, on this one we have x to the power of negative 4. Remember that this states that if we have base to the negative power, we can rewrite it as so. Then this becomes x to the power of negative 4 is the same thing or similar or equal to 1 over x to the 4th. Notice how the sign changed in the exponent. Similarly, we have 5 to the negative 3. This becomes 1 over 5 to the positive 3, which becomes 1 over 125. Right? Positive exponents only when simplified if possible. So we have 4 over 5 to the power of negative 2. This I can distribute that negative 2. So this becomes... Now, a minute ago, it tells us that if we have a negative exponent and it's in the numerator, change it to the denominator. And if we have a denominator with a negative exponent, change it to the numerator. So we're going to be doing that on this one. So this one will become pretty much a switch. So we have 5 to the power of 2 over 4 to the power of 2, which is 25 over 16. Similarly, here we have 1 over 7y to the negative squared. This telling us that the 7 is not being affected by that negative 2 because we don't have a parentheses. Therefore, this stays the same. The one that's going to switch is the y. So that goes up to the numerator. And we have a squared over 7. Also, it's like the problem we had before with both negative exponents. So we have x to the negative 1, y to the negative 8. We're going to switch them. So it becomes y to the power of 8 and x. Simplify exponential expressions. So this one, I'm going to distribute that exponent 3. So this becomes 2 exponent 3, 2 times 3 over 5x to the 8th. 2 to the power of 3 is 8. 2 times 3, which is the exponents of the x in the numerator, will become a 6 over 5x to the 8th. Okay? Now, this can be done in two different ways. I'm going to show you the one like we did before, and after that, I'm going to show you how it's supposed to be done using the negative exponents. So this one will become like we did before, so I'm going to use blue. So I have 8x to the 6 over 5x to the 6 times x squared. This cancels with this, so we have that 8 over 5 x squared. That's our answer. Now, following the book example for this one, this becomes 8x6 minus 8 over 5. We can do that because of the power. How we can send the powers to the top if they're negative. We can go back. So here we have 8. We're sending it to the top, so this becomes x minus 8. Which becomes 8 negative to the power of x negative 2, 5. We don't like that negative 2, so we're going to send it to the bottom, and we have like so. You have to remember that this one states that if we have the same base, then the exponents will add. So we have x to the negative 12 times x squared. We have the same base. That means they can add like so. But we're not done because we don't like that negative exponent. So this becomes 1 over x to the 10th. So this one I can rewrite as 75 over 5 times x3 over x9. 75 divided by 5, that's going to give me 15. Then x cubed minus 9, because of we can send that exponent to the top. We'll have x 15 to the negative 6, which later becomes like so. So let's first work with what's inside the parentheses. So this we have x8 over x to the 4th to the negative 5. This one I can rewrite 8x times x to the negative 4 to the negative 5. They have the same base. That means they can add. So I have 8 minus 4 to the power of negative 5. 8 minus 4 is 4. So I have x to the 4th to the negative 5. That means that the exponents, they're going to multiply. So it becomes x to the negative 20. We're almost done, with the exception of we don't like that negative to the negative 20. So that becomes x over x to the 20. Scientific notation. A positive number is written in scientific notation when it is expressed in the form of 8 times 10 to the power of n, where a is the number greater than or equal to 1 and less than 10. 1 is less than or equal to a, which is less than 10, and n is an integer. Convert scientific notation to decimal notation. At times, you may find it necessary to work with really large numbers or alternatively, really small numbers. Here you will learn how to write this often cumbersome numbers in scientific notation. We can use n, the exponent of the 10 in a times n to the power of n, to change a number in scientific notation to decimal notation. If n is positive, move the decimal point to the right and places. If n is negative, move the decimal point in the a to the left of absolute value of n places. So if we have 7.4 times 10 to the power of 9, that means I have 7.4, and I'm going to move this decimal 9 times to the right. So this becomes 1, 2, 3, 4, 5, 6, 7, 9. So our decimal is going to end up there, and these will all be zeros. 4, 5, 6. So this becomes 74, and then 2, 4, 6, 8. 1, 2, 3, 4, 5, 6, 7, 8. Comma, 1, 2, 3, comma, 1, 2, 3, comma. Now, on this one, on the next problem, we have 3.017 times 10 to the negative 6. Now we're going to be moving the decimal to the left because of this negative. So I have 3.017. I'm going to move it 6 times. 1, 2, 3, 4, 5, 6. So our decimal will end up there. So I have 0, 0, 0, 0, 0. So our solution is 5 zeros. 1, 2, 3, 4, 5. 3017. Convert from decimal notation to scientific notation. Converting from decimal to scientific notation, determine A, the numerical factor, move the decimal point in the given number to obtain a number greater than or equal to 1 and less than 10. Determine N, the exponent on 10 to the power of n. The absolute value of n is the number of places the decimal was moved. the exponent n is positive, the given number is greater than 10, and negative if the given number is between 0 and 1. So let's see an example instead of just guessing. So we need to put our decimal place right there. So if it's right here right now, how many times I'm going to move it? 1, 2, 3, 4, 5, 6, 7, 8, 9. So this becomes 7.41 times 10. And since we moved it 9 times, it's going to be to the power of 9. Again, we need to put it between the first and the second coefficient. So it's 1, 2, 3, 4, 5, 6, 7, 8. So this is 9.2 times 10. But since I moved it to the right, this will become to the power of negative 8. Compute with scientific notation. Multiplication. Notice like the multiplication stays the same. And the exponents will be adding because they still have the same base. On the next one, we'll have the same thing for the coefficients, or the a and the b. And we're still following the rules of exponents. That means since they're dividing and we have the same base, then the powers will subtract. And the exponent will be distributed between everything on exponentially. So let's see. So this we have 5.41 times 10 to the negative 6 times negative 3.2 times 10 to the negative 8. So we're going to do the multiplication. So the multiplication on this one would be perform the indicated computation, writing the answer in scientific notation. So we have to separate this, and I'm going to put 5.41 times negative 3.2 times 10 to the negative 6 times 10 to the negative 8. So we have 5.41 times negative 3.2. That's going to give me negative 17.312 times 10. Since we have the same bases, the exponents will be adding. So negative 6 minus 8. That's negative 17.312 times 10 to the negative 14. But we need to put our decimal between the first and the second number. That means I need to move this once to the left. This will leave us with negative 1.7312 times 10 to the negative 13. And that 13 comes from this move of decimal. So we have performed the indicated computation, writing the answers in scientific notation. So we have negative 3.2 times 10 to the negative 8. And then we have 5.41 times 10 to the negative 6. So we do the division of that thing. So we have negative 3.2 divided by 5.41 equals negative 0.591 times 10 to the negative 8 minus negative 6. Remember that we have the same base. The exponents will subtract. So we have... So this is because of that formula on top. And this second negative is because that's how it came. So now we have negative 5.591 times 10. So negative 8 minus 6 is negative 2. Now we need to move this one to the right. So this becomes negative 5.91 times 10 to the negative 3. So this is 3 times 2 times 10 to the 8th times 10 squared. So this becomes 6 times 10, 8 plus 2, which is 6 times 10 to the 10. So this becomes 4 cubed times 10, negative 2 times 3. That's going to be 64 times 10 to the negative 6. But we need to move the decimal one place, so it's 6.4 times 10 to the negative 5.